Okay, so if you've ever built an LWC and then just stared at a blank page wondering where your data went, this deep dive is definitely for you. We're cutting right to it today. The absolute must-know shortcuts for solid LWC development. We're talking real-time debugging in the browser and really comprehensive just unit testing.
Exactly. These are the two pillars, right? They solve the biggest headaches. First, fixing those bugs that pop up right now when the component is running. And second, making sure your logic actually works in isolation. So those bugs hopefully never even show up at runtime. We're aiming to give you just the essential non-obvious techniques you need for both.
All right, let's dig into the debugging side first. Everyone kind of knows the basics. Browser dev tools, setting breakpoints, maybe dropping in a console.log here and there to check, I don't know, if the set recorded actually has a value before you try to save something.
Standard stuff, yeah. But the real game changer, the thing too many people skip, it's the Salesforce LWC DevTools extension.
Yes. Secret weapon.
It really is like having X-ray vision for your components. You can see the whole hierarchy, the reactive properties, public and private track, custom events.
Yeah.
But, and this is a big but,
it
won't give you that useful view unless you do one specific thing. You absolutely have to enable custom formatters in your Chrome DevTools settings.
Oh man, I remember burning like half a day because I missed that. You just see generic JavaScript objects otherwise.
Exactly. It's completely useless without that checked. A total non-negotiable. Make sure you enable it.
Okay, noted. Enable custom formatters. Speaking of things that can silently trip you up, the LWC lifecycle. Specifically, I'm thinking a rendered callback.
Oh, the rendered callback trap.
Yeah.
Yes. Big one. Because it can run, well, potentially loads times. Any heavy lifting in there, like serious DOM manipulation.
Yeah.
If you do that without some kind of check, performance just goes off a cliff.
So you need that little Boolean flag, right? Like this dot is rendered true or something.
Precisely. Just a simple flag to make sure your setup code, your expensive stuff, only runs that first time it renders.
Makes sense. What about the other place errors love to hide? Asynchronous calls, like calling Apex or using the fetch API.
Yeah, that's the next major risk, async safety. When you make an imperative Apex call, for example, that promise might fail silently. No obvious error sometimes. So the gold standard really is you always wrap those calls in a try.catch. Always. And you need a .catch block on the promise itself too. You got to log that error somewhere. Developers can see it and show a helpful message to the user so they're not just stuck.
Okay, so try.catch plus a .catch for async. Got it. So that helped us find problems at runtime. Now let's switch gears to preventing them in the first place with just testing.
Right. Isolated validation. The basic setup is pretty standard. Import the component using create element, append it to the document.body, and then check things. Validate.
But LWC throws a wrench in the works there, doesn't it? With the shadow DOM.
It does. Shadow DOM is great for encapsulation, keeps things secure. Yeah. But for testing, it means your standard document.query selector just fails. It can't see inside the component's template.
So how do you get around that?
The absolute key, the thing you must remember, is component.shadowroot.query selector. You always use that shadow root property. That's your way to pierce the veil, basically, and find elements inside your LWC for testing.
Component.shadowroot.query selector.
Okay, crucial. But even once you find the element, there's another timing issue, isn't there? LWC rendering isn't instant.
Correct. Another async trap. If you change a property on your component in a test, you can't immediately check if the DOM updated. LWC needs a moment to re-render.
So you have to wait somehow.
Yep. You need to wait for that render cycle to finish. The common trick is using something like return promise.resolve. Think of it like telling Jest, okay, pause for just a tiny moment, let any pending LWC updates finish, then run my assertion. Sometimes you might need a set timeout for more complex cases, but promise.resolve handles most microtask queue flushing.
Right. Give LWC a tick to the clock. Okay, let's talk efficiency then. Apex mocking. Super important for fast, reliable tests, but let's be honest, it can feel like a bit of a hurdle to set up initially, right? It can seem that way, yeah. But the payoff is huge. By using just manual mocks, that jest.mock function, you tell your test, hey, when the LWC tries to call this Apex method, don't actually call Salesforce. Just return this fake data I've prepared.
Like a simple JSON file mimicking the Apex response.
Exactly. Success data, error data. That way your test runs instantly, doesn't need a network connection, and it only tests your component's logic, not your Apex controller or the whole Salesforce backend. It isolates the unit.
Makes tests much faster and way less flaky. And the ultimate efficiency move. taking complex logic out of the component entirely.
That's the cleanest approach, definitely. Separation of concerns. If you have really complicated calculations or data transformations, put that logic into its own separate JavaScript module. Then you can write jest tests for just that module without even needing to render an LWC. Super fast, super focused.
Okay, so let's recap the core ideas here.
For debugging, it's about real-time inspection. Use the standard tools, but definitely get that LWC DevTools extension working. Remember custom formatters, and watch out for lifecycle traps like rendered callback and async errors.
Use try.catch and .catch.
Absolutely. And for testing, it's isolated validation. You got to use component.shadowroot.querySelector for the shadow DOM. And you need to handle the async nature of rendering, usually with promise.resolve. Mock your Apex calls.
So the big takeaway is debugging shows you what's happening now. Testing proves your logic works in isolation before it even gets to the browser.
Pretty much sums it up.
All right, final thought to leave everyone with. We talk about aiming for high test coverage, maybe that 90% mark from the Just report. That's good, it builds confidence. But here's the provocation. How much confidence do you really have if your coverage report shows you've never actually tested your error handling paths?
Good point. If that .catch block we talked about or your component's error message display logic never runs in a test,
You can probably assume it's broken in production. So go test your failures, make sure your error handling actually works when things go wrong.